We learned about voltage and current. So voltage and current allows you to light in light bulb and an LED and many other things. So here I have a 9-volt battery, and each side has negative side and a positive side. That corresponds to each terminal. So the shorter part on the left is the positive side, and the longer one, the big one on the right, is the negative terminal. And if you have trouble with deciding which one, these signs will help you. And if you don't know the voltage of this battery, it says it right here, 9 volts. So let's say I want to light up an LED. Is it possible? Well, you need a voltage source. So this is a voltage source. It supplies 9 volts of battery. So here I have an LED, and I'm gonna bend these leads a little bit to fit with the terminals. And the longer leg is the positive terminal, and the shorter leg are the negative terminal. So let's see what happens if I try to light up an LED just using a battery. So, oh boy. Actually, no, this is not. You hear a spark. And even worse, the LED burns out. Why is that? Well, that's because we don't have anything that limits the current. So it's kind of like a short circuit. And a short circuit is when the positive connects with the negative part of the voltage source. And when that happens, current is limitless. So what's our solution to this? Well, stay tuned. Hello everybody, this is King Tut here, and welcome to your 4th Electronics 101 tutorial. In this tutorial, I will teach you guys about resistor. So what is a resistor? It's an electronic component that resists the infinite current flow. So without resistor, and you connect from the positive to the negative, that'd be called short circuiting. And in short circuit, current goes out of control. Voltage is going to be the same, but current will go out of control. Resistor, if it's put in series with each other, reduces voltage. And it also converts electricity to heat when it passes by the resistor. And it comes in different power ratings. So what I mean by power ratings here is if it goes above the certain power rating, your resistor will more likely to be burned. So for example, a 1/4 watt resistor, which I have, if it goes below a 1/4 watt, that you're fine. And if it goes above a 1/4 watt, your resistor is going to burn out. So it could be any voltage, it could be any current going through resistor. It doesn't matter the voltage or current, as long as it's either equal to the power rating or below the power rating. Ohms is the unit of measurement. So to measure resistance, you use ohms. And you use omega to describe, let's say, 220 ohms. Instead of putting ohms, you put this omega sign on it. And most resistors are carbon film resistor. Basically, every resistor you use are carbon film resistor. And symbol for resistor in the United States is the one on the left. And the symbol for the resistor for Europe, usually Europe, but it might be used internationally, this one on the right. Sometimes it's being used in the United States, and you might see it in some circuits online, industries, so on and so forth. So the anatomy of the resistor here, so they're connecting leads, so every components that have these wires sticking out are called leads. Then you have the end cap, it goes into the end cap, and it goes inside this carbon film and ceramic substrate, and it reduces the voltage and it makes the current constant instead of out of control. And it's kind of like friction. And if you don't have friction, we'd be sliding forever and ever and ever. So how do you tell how many ohms in the resistor? So you could either use an ohm meter or color banding. So color banding here is basically the first, let's do 4-band for example. The first two numbers, the first two bands, my bad, are basically significant figures. And then here you basically multiply these two bands by this. So let's do an example. Gray here, if you look at the table, will be 8. Red is 2. And then here, orange, let's look at it. It's 1K. So it becomes around 82 kilo ohms. And then right here is gold. So gold here, the one on the last part of the resistor, is tolerance. So sometimes there's some colors that represents different tolerances. If it's brown, it would be 1% tolerance. If it's red, it would be 2% tolerance. But since this is gold, it has 5% tolerance. And don't worry about the letter. I personally don't know what these mean. But if you have any trouble with any of these resistors, you could go online and just put in resistor color banding or color code, and you'll have a lot of resources for that. Alright, so let's get into the demonstration. So we're demonstrating how a resistor works. So here I have connected the resistor to the positive leg or the positive lead of the LED, and this is 220 ohms. That's because it has red, red, black. This is a 4-band resistor. I'm not sure if you could see it clearly. Let's make sure. Yeah, okay. So it's not as clear, but it has red, red, black, black, brown. So the first two red, they represent a value of 2 according to the table. Black is 0. And then the second to the last one, which is black, is it has only one multiplier. So 220 multiplied by 1 is 220. And then the brown at the end here is 1% tolerance, which means it could be 1% higher than 220 and 1% lower than 220. Alright, so let's connect it to the battery. Here I adjusted it so. Let's get it in focus. Hopefully. Okay, it's in focus right now. Now it's in focus, okay. And then right now, when I connect the LED, alright, this is going to take some time. When I connect the LED, should light up. And it didn't even burn out because I've made use of the resistor. So you see here, I have struggled to actually put that into the battery, to connect it to the battery and get it to light up. In the next tutorial, I will show you a better way to connect the batteries with the resistor and the LED.